Hi there, and welcome to another FlipChem video. This time I'm going to go through a past paper question on time of flight. The question details and format are on the screen now. Let's get started. Here's the question. A sample of titanium was ionized by electron impact in a time of flight TOF mass spectrometer. Information from the mass spectrum about the isotopes of titanium in the sample is shown in the table. Calculate the relative atomic mass of titanium in this sample. Give your answer to one decimal place. M over Z is the mass over charge ratio. In the ionization process, the majority of atoms lose one electron to become 1 plus ions, so mass over charge is equal to the mass of a particular isotope. The mass is in atomic mass units. If there were 100 atoms, multiplying the mass of each isotope by their percentage abundance gives the total mass of 100 atoms, so dividing this number by 100 gives the average mass of one atom. Here's the next part of the question. Write an equation including state symbols to show how an atom of titanium is ionized by electron impact, and give the M over Z value of the ion that would reach the detector first. Atoms have to be ionized so that they will accelerate through the flight tube and so that they will produce a current that can be measured at the detector. One way of doing this is by firing electrons at gaseous atoms in a sample. These electrons knock another electron out of the atoms. You must include the state symbols. The atoms and ions are gaseous. Ions with a lower mass travel the fastest and will reach the detector first. Here's the next part of the question. Calculate the mass in kilograms of one atom of titanium-49, and we're given the Avogadro constant there. Well, 1 mole of titanium-49 atoms has a mass of 49 grams. Dividing this by Avogadro's number gives the mass of one atom in grams. Dividing this number by 1000 gives the mass of one atom in kilograms. Here's the final part of the question. In a TOF mass spectrometer, the time of flight T of an ion is shown by the equation, and the equation is given there. In this equation, D is the length of the flight tube, M is the mass in kilograms of an ion, and E is the kinetic energy of the ions. In this spectrometer, the kinetic energy of an ion in the flight tube is 1.013 times 10 to the minus 13 joules. The time of flight of a Ti-49 ion is 9.816 times 10 to the minus 7 seconds. We need to calculate the time of flight of the Ti-47 ion, and we need to give our answer to an appropriate number of significant figures. Here I have abridged the question, leaving only the essential information. We have data associated with the titanium-49 and titanium-47 isotopes. First, rearrange the equation given in the question to make D the subject. It's always worthwhile doing this before we put any of the values in. Next, put the data in for the titanium-49 isotope to find D. All ions travel the same distance and will have the same energy. Next, we put the data in for the titanium-47 isotope into the equation to work out the time of flight for this isotope. Thanks for taking the time to watch this video. Take care and goodbye.